Check 1 2. This is working. I have audio. Hello, hello. I think the audio is not working. Yeah, the audio is working. Okay, so that's good. I think that's okay. I think this is a good view. All right. Yeah, that's sort of working. Okay. I think that's better. Yeah, there we go. All right, so sorry about that. They're just trying to set the camera. I don't do these lives very often here. Nothing specifically planned, just thinking out loud, I guess. People are wondering why I'm not doing experiments lately. It's just slow times. It's winter. It's cold. Um, Funds is an issue too. I've got a bunch of parts ready to order at the end of the month here, which I will get to. But in the meantime, I guess just figure out what I want to do next here. I would like to do a little cleanup in my parts here. Thanks to all your support, of course. I got a lot of stuff. It's just putting everything together, but you're always missing that one thing, right? I wanted to do experiments with barium ferrite. Someone was nice enough to get it for me, but it didn't make the border. So now I'm just looking for barium powder. I have ideas of if those are we're watching for my ferroelectric, piezoelectric capacitors here, nonlinear capacitors. And I was going to build my own semiconductors. And yeah, my point is, there's always like one little thing missing when you want to do experiments but it helps, as I get along, I get more parts. But being in a little apartment here, you've got to put that all in a bin or two when you're not using it, and then it gets a little unorganized when you want to do something, and it's all there. So that's where I'm at right now. So this is basically my little corner of research. These are schematics that I've made here. This is displacement current to real current transducer, one-wire system, no return path by Joel Legacy. I actually showed this in a video. Maybe not everyone has seen it. I don't know if the camera will catch that or not. Seems a little blurry, isn't it? But yeah, I have a video of this. It's really clear in the video. I've been doing a lot of one-wire experiments. I took a break because I was having some side effects. And folks, when something happens that I can't explain, I don't like it. And what was going on basically is the more, like when I started playing at 150,000 volts or more, if some of you have been watching earlier, I was actually having issues with ball lightning. It sounds really strange, right? But it was happening, and it happened more than once. And always after my experiments, shortly after, it could have been an hour or two, and it would maybe last a couple days. So But what seems to be the thing that stopped it all, I'm sorry, my dog is in my wires here and we're live. Poofy! Yes. Okay, sorry about that. The wonders of being live. Poofy, no, no. You're not part of the show. Thank you. Go lay down. Go lay down. Poofy, go lay down. Good girl. Yeah, and my dog was sorry about that, getting on my camera wire and it was vibrating and didn't want to fall off the base, you know. So, what was I saying here? Oh, yeah, the ball lightning issue. So it kept happening, and at first I wasn't sure what was going on. And the common thing was it was always when I was doing the heavy side experiments along the one wire system. And I did some more research into this, and Tom Bearden has this site archive, and he specifies that under the right conditions, when you start messing around with the heavy side, such things can happen along your antennas because you're creating potential differences. And some of these fields, it's an unknown part, not unknown, but ignored part of traditional electrodynamics and very poorly understood original extended 20 variables of Maxwell here. I've talked about those a lot. I actually built a wiki, typewrite.social, basically the form URL without the dash form. That'll take you to the Maxwell wiki, and I've tried to detail it as much as I could, the 20 original variables in his equations. It's a lot to get into, so I'm not gonna spend an hour on it here. Just talking out loud here, thinking out loud. But I just found these here, but I don't need this right now. So let's see. Meter, I'll probably need that, so I'll keep this here. This, folks, is interesting. It's a Hack RF1. It's an SDR transceiver. It works like heck trying to get it to work on Windows, but there's certain softwares like SDR Angel, which offers various modulation settings. And the output is around, there's a few milliwatts of output, but it'll drive amplifiers. It'll turn transistors on and off. You see where I'm going with this? It was my attempt at trying to build a fancy controller. This works up to 6 gigahertz. So those that were wondering about what happens in the very extreme high frequency ranges, this is something you might want to look into. Experiment in progress. I haven't actually stepped on that domain yet. I think the highest I experimented with was something like 22K. But yeah, the capability is here. The tricky part is how do you build waveguides at such high frequency without the loss? And it's an issue when the LC circuits at microwave bands, I mean, they're so small, you know, it would almost have to be a microscopic surface mount kind of thing. But the point is, doesn't need to be in the microwave bands either. It could be 20 megahertz. That'll work as well. A lot of possibilities here. I never quite scratched the surface of this yet. When I did try it, it worked a little flimsy on Windows. Works a lot better on Linux. I had a Linux workstation, but it's in the closet right now because space-wise here. So this I won't need, but I need to make space. Put this over here. Capacitive power supplies. Here's one of my solar panels. I want to experiment with nighttime solar here, but I need to do a few modifications to the cells first, and I'm still waiting on parts for that. But there is a mechanism that I will shortly be showing everyone here. And I'm sure you folks are all going to think it's really interesting. So with that said, a little hint of what's to come. I'm going to put this, I think, up here for now. This is the lamp I use to test my various back EMF projects. Foofy, shh. I'm sorry about that, folks. The wonders of being live. All right. So let's see what else here. Oh, hot glue. Yeah. I'm very hot with my hot glue. Use it a lot. You know, folks, call me silly, but it's an easy way to isolate your circuits and keep them in place with your wires and things, especially when you're building everything on a piece of cardboard like I have with some of the projects here. I guess you use what you can to work with. Oh, this is really neat. This is a Bluetooth wireless speaker. I ripped the speaker out and tapped my ground and positive here and put a circuit board so I can go like this here. And then I use a pulse generator program on the computer, audio, and this becomes my controller. It's got a little amplifier in here, so it actually can deliver about a watt, and it's Bluetooth, and it's isolated from my, the input and the output, because it's got its own battery supply in here, and it charges from the USB port. I'm sure one day I can get the whole thing. If I were going to replicate a Bedini-like setup, this could probably self-charge because it's really low power. It's a good trigger. Just something else I had in mind. There's a lot of things that I actually have, folks, that I never made videos of, and I feel that it would be irrelevant or people wouldn't be interested. But I'm always doing like interesting things in the background here. So I just thought I'd share this. I actually made a pulse generator application that I shared not a long time ago on the forum. It's an actual browser app. You pick your frequency duty cycle. It would work very well with something like this. So yeah, another option. But I wish I had like little boxes or something to put all this stuff, because I got a lot of stuff here. And I don't like creating a mess for nothing. Sometimes it's not by choice. Speaker. This is parts. These are rare earth magnets. I got a bunch of these from China. Very strong magnets. There's hints out there that, according to Bedini, barium ferrite or rare earth magnets could be driven to a state of self-oscillation. Now, Floyd Sweet was only able to do it with certain barium ferrite, but he tried with regular magnets too, and apparently failed. It was going to be another project of mine. A lot of projects I have that I don't actually complete because, I'm always like missing that one thing. And it's not always the main focus, right? People want to see this free energy stuff, but this is related, of course, but may not be directly the solution to what everyone wants. But I still have an interest in it. But I don't want to spend money in this either when people are waiting for the better stuff, right? So I got to prioritize what I want to do and still remember where all the parts are for when I actually do end up with everything. So So let's see here if I can put this. I could maybe put this in here. This thing is pretty neat. It's the radiation meter. Very small these days. I use this for, to detect the ionizing radiation. And it works very good for scalar waves and the one-wire system because it's in the name, right? The ion valve. So if you've got ionization going on, I want to know if I got strong ionization. It drives this thing here. So I have it on. See if there's any background radiation today. There was one click there. Oh. Sometimes the most random things will set it off. People have no clue some of the stuff they add in their food actually has radiation. Look at this. This thing is clicking here, and it's a what am I looking for? The word here, carbon base and vinyl, I believe. It's a scrubby. Pretty quiet background noise tonight. Anyways, enough of that. Don't want to waste the battery for nothing here. I also have somewhere, if I can find it, the old style one. This is, what is this? Oh, a whole case of diodes. I'm going to need this. Fast recovery diodes. So I'm going to put this aside because I'm going to want to use that. Microwave capacitor, not supposed to be there, but it is. Oh. The joys of not having the room you want to have, right? And this here, oh, more diodes. And again, a lot of this, folks, I have to say, comes from all of your support, donations of parts that you've sent me. So very much appreciated. Couldn't do all these experiments without your help. Zener diodes, 33 volts. I might need this. It's a high volt. Oh, a lot of stuff. But always missing. So I guess we're making good use of the time. Instead of doing nothing, trying to put my nice word for it, things in order. All right, so there's nothing I'll need here. Got a lot of transformers, folks, but ironically, I don't have one set that's actually the same. I want to do phase cancellation experiments, and you need identical transformers for that to work properly. Something else on my list. See, this is a very interesting kind of resistor. It also is a coil. So in RF systems, especially something like Don Smith, this is variable, but it don't have to be. You slide this here and it varies. And this one here happens to be, I believe, it's 1K, which is pretty good range, and it handles 100 watts. See, these are actually very high power resistors, which are also coils. So they are very friendly with RF systems. You just got to watch your impedances a little here. And again, you know, this could be a component to use in a Don Smith like setup, because technically you could have an RCL network, right? I mean, it is part of the Ohm's law, I believe. So I've seen this in old time radio tuning circuits as well, and dummy loads and things like that. So yeah, this is a very interesting piece, even some history to it. So I'm getting there. These are all my lead wires. I'm gonna have to make my own. There it is. I've got all these loose wires because I've been playing with the one wire system and using antenna and wire grounds. Loose wires all around the place, but as I specified, you know, got to figure out the ball lightning thing, because maybe it won't be an issue outdoors. So here's one of the wires I'm going to use. It's just connecting wire. There's one piece. And I love these things, but they're so cheap, the ones I got. The solder joints, and they can't handle any real current. Not that we need it, but especially for back EMF projects, this causes such a waste. I'm gonna need this here. A one wire system I was working on with all my, some people call the AV diode plugs here on every winding here. I was getting a lot of voltage with this. So I will put this aside. I do have an idea of a few things I want to try with it. Oh, this is something that I find if people want to have high voltage, like the flyback devices, you get the dollar store fly swappers, just like this. Take them apart, and what comes out here is pulse DC at a couple thousand volts, few thousand volts actually, to zap the flies in the grid. But for some high voltage projects, worst comes to worst, you could use one of these. Tools. Starting to see my space again here. Okay. So down here. Just got a bunch of magnets down there. There's another connecting wire. Need this. So, what else do we have here? I gotta get to. Oh. Here's something I can try and fix. This was something like a Bedini solid state charger I worked on. And I had an issue with it. I had a wire that was disconnected and never finished it. I never featured this one in the video here. And I did a pretty good job actually with it. And I got outputs for external batteries here. And everything runs in the box. I even have a switch to turn it on and off. And an LED indicator light inside that tells me if it's working or not. Now, the clever thing I did here is I used a low voltage AC power supply, no rectifier. So the output here is 18 volts AC, 500 mA. So I figured to use the AC and keep it as AC, I've got a rectifier diode in here with no filtering cap just to get the pulse. So essentially, I also have X capacitors in here to knock the current right down, so it's reactive. And that reactive low amperage 60 hertz is pulse DC charging my batteries here. So let's see if I can take this apart and see what I originally did wrong here. Because it was an idea I had, and then when I noticed it didn't turn on, I said, I'm not opening that up, I'm going to do something else. Now that I have the time, because I am curious if it would work the way I thought it would. So I'm just going to head over to the computer in case someone's trying to get my attention here so I can answer. Big crowd tonight. So when I'm reading, I don't even know how many are here. I don't really do the live thing very often. So far, I haven't seemed to have missed anything. Good day all. So there we go. Just a little update on the chat. Now back over here. Hopefully it was just a wire. Okay. There's one screw that's out. Okay, what went wrong here? What went wrong? That's there, that's there, that's there. I wonder what oh, it's, there's the negative side is unsoldered in here. Okay, plus is here. The negative side down there. I see it. Okay. So here's the inside, folks. I don't know if you can see that properly. I would need more light. But yeah, basically this is just a capacitor and a rectifier in here, and the connection box. Resistor here doesn't do very much. It's just to handle the spikes in the reactive, because when you turn it on initially, it takes a moment. I don't know if this is blurry or not. Oh, there we go. So that's what this is. So now I got to connect this to here on my rectifier here. Got to find a little wire. Just a little jumper. This one here will do. Right. And I need to get more flux soon. Okay. Now, why is this turned off? Well, maybe if I plug it in. All right. wait a moment for this to warm up. And I would need some small pliers. Okay. This is there. There's plenty. Sponge here. I lost my little sponge. This I'll have to bend it. That. Clean that later. More of my work table. This is why it's an old cover on top of it, because I know I make a mess. I shake a lot. Perfect. So now, got it on the wire. It's going to have to be more like this, like that. Hopefully I'll get it first try. I'm not good at soldering at all. See, this is what happened the first time, so, but I guess there's plenty on there. So let's give it a shot. Oh, this is still not lined up completely here. All right, let's try again. What's my temperature here? It's pretty high. That shouldn't be a problem. Just didn't get it. Bear with me, folks. Like I said, there was no specific plan. I just saw this and said, oh, I should work on this. So here I am. Wasn't intending on any projects. And suddenly, this comes up. There we go. guess it would help if there was a bit of solder on there. Now I'm shaking a lot. I think my medication is, what time is it? For the tremors is when that starts. Ay, ay, ay. Just my everyday struggles. I don't want to bore you all with that. Still got to do what your passions are, right? But this is why I like to have a better setup down the line where I could use my hands as least as I can and get all of this. Yeah, I might be done for the night here for soldering anyways. I can't quickly get it. Yeah, so that's the issue with me sometimes when the shaking starts. It just starts like that, you know? And usually when I'm in the middle of a project, it's not bad, but it's when I'm very precise, you know, trying to put a screw in a little hole, then it gets really. But we all have our issues, right? I guess it could be worse. And I started off no problem. I was so still. And it was just a matter of getting that wire in there, and it all started. Okay, this might not happen. So you know what I'm going to do? It's too early to, can't take anything for it right now. So what I'm going to do is I'm just going to do what I normally do, which I don't like doing. Just bypass it for now and clip it because I really want to see if this works. So I'm just gonna simple done like that. There we go. For testing purposes, it's activated. Okay, so the power supply is right here. Actually, it's a transformer because it's AC. 18 volts AC. So I'm just going to find my power bar down here. Plug this into the power. Right here. Like that. Switch is on. Hopefully when I plug this in, nothing goes poof, right? Okay. That gave me a spasm. Oh. Yeah. Just got a spasm in my neck here from. Sorry, folks. Just I guess it's a bad night. All right. see if this is working. LED is on. That's plugged in, that's plugged in. Maybe. It's not right. Everything seems right here. Let's see if I got a waveform. Maybe there was something else and I don't remember no more. This was like a year ago. So, project that got abandoned, maybe there was a reason. So let's see if I can figure it out. There's ground here. There's plus here. My muscles are doing garbage this evening, folks. I'm sorry. What I'm going to do, use this. Put the probe in there. Plug it in here. Like that. Then my ground. In here. Like that. It's basically nothing. No. Yeah, so maybe there was something here. Maybe I had a bad part or something. I don't remember. So this is plugged in. Switch. There's power here. Something else. Maybe it's just these things here. So there's the power. That connects down there. There's the plus here. That's all fine. Everything seems fine. Maybe I burnt out the power supply transformer. It's been so long. This was actually before I started putting videos on YouTube. I had this weird idea one day. Maybe it is a weird idea. Oh, I see. I see it now. I didn't realize I got a voltage regulator on the side. Okay. I think I see what's the issue now. Yeah, this is going to be a project for another day. I had an idea here, and yeah, I see that now. I thought it was straight I thought it was right to the transformer and out to the rectifier, but I have a whole circuitry going on here. All right, well, no big deal. At least now I remember, now I know. It wasn't lost. I did a good job at hiding that. I really did. I guess A+ for effort, but I'm sure the concept would work. I just gotta go back to the drawing board and actually build it. But I am curious if this transformer is working now. So I will find out. Yeah, that transformer is working. So I'm going to put that back on the back burner. Now at least I remember what the big issue was. I had totally forgotten, folks. I really didn't remember why. All I remember was it wasn't working. I thought it was a wire. It was a wire, but it may have shorted out when it disconnected. I have a voltage regulator in there. And the LED, nothing is turning on, so. All right, so. Something that interests me while I'm at it. I wonder since this is 60 hertz, but low voltage 60 hertz, I wonder if this could be used for a project here. So I'm going to try this again. Okay, plug it in. So 60 hertz, there it is. That seems to be fine. Okay. So my idea, which I don't have anything to test it with right now, would be this would be a waste on its own, but maybe with make it reactive, maybe like I wanted to do. And since it's reactive, it would lower the current usage quite significantly because this is still 500 mA at 18 volts AC here, which it says on the input side, 120 volts, 60 hertz, 11.5 watts. I don't want to use 11.5 watts. But what I'm getting at is, could we do like a Bedini kind of setup where once we make it reactive, even though it's 50, well, the duty cycle, there's no such thing on an AC. In essence, it's an alternating sine wave. But for half the time, you know, it's one polarity, and the other half the time, it's the other polarity. So, we rectify the output, so we get pulse DC. It won't be a spike because of the way the AC works, but we'll have DC output kind of pulse. The amplitude will vary during the what part of the cycle it's at. That's what's going to happen here, but it'll be DC. So okay, so if it's going to be DC and and it's reactive, I wonder if we could pulse a coil with it and feed, you know, back EMF, or the inductive kickback in better terms. And instead of having all that circuitry, just use this with a reactive stage, pulse the coil and use the back EMF side or inductive kickback to charge batteries. See, I don't know if I really want to get back into that or not, the Bedini stuff. I'm more focused on the one wire stuff. But there is a lot in the Bedini that by design and my limitations that I wasn't able to cover. Multiple coil systems is something that comes to mind. And I think I actually have a design for that I wanted to test. Maybe that's something I should try. All right, folks. I mean, I pretty well did what I could do tonight. I didn't expect all of the tremors to kick in, but it did. But yeah, I mean, waiting for parts. Once that gets rolling, I'll have more experiments, more organized, something to actually talk about here. But this is just to show you folks, you know, on a regular evening, just random putting around. And sometimes it's just by doing this kind of stuff here that oh, this works. I should tell the people online that this works. And next thing you know, I make a video on the spot, you know. But there could have been an hour or two of just, you know, doing whatever, and then suddenly, oh, here's something. So with that said, here it is. It's not that late, 7:15 p.m. I'm going to have to basically put away the dishes and do that there because we had dinner. Like most people do, I guess. Nothing new there. This is a home, so it's not just a shop. This is my spot here, my table for all of my... I got this area in the kitchen, and the rest is a normal place. So with that said, I hope you enjoyed a bit of insider here. And I shall cut this short for now. And again, thank you for watching and your continued support. And I hope to see you all again soon, folks, and have yourselves all a great evening. Thank you. Okay, just trying to. There's a few comments here. Just gonna wrap it up.